polynomial. We've seen these before. These are the linear polynomials. And a good linear polynomial, we've seen these all before. Any line, so like 3/2 x minus 4 would be a great linear polynomial. It wouldn't have to have two terms. You could have something like y equals 4x. That would be a great linear polynomial. We started at 1, but there's actually one with a lower degree that we should mention. You could have a degree 0 polynomial. It's kind of weird. There are no x's at all in something like this, right? Because the power on that x would be a 0, and anything to the 0 power is 1. So that would actually go away. So if you had something like 3x to the 0, that's really 3. So any degree 0 polynomial is actually just a number, and we call those constants. Right? Constants don't change in value, right? There's no variable there, so it doesn't vary. It stays the same. So any nice whole number, any fraction number, frankly, would work as a constant. Right? So we've got 0, we've got 1, we've got 2. We've seen these as our quadratics. Right? Anything with a second power. So like y equals x squared minus 4. That's a great difference of squares polynomial, right? Anything with a power of 2 works for that. All right? Degree 3. This is a new one for us. This is a cubic polynomial. So anything with a third degree is a cubic. So something like y equals 3x cubed minus 17x would be a cubic polynomial. Again, its highest power is a 3. That's how we're determining which category these fall in, their highest power. Let's do one more, fourth degree polynomial. So again, anything with 4 or more, we're just going to call it an nth degree polynomial. Again, anything with 4 or more, we're just going to call it an nth degree polynomial. So anything bigger than 4, including 4, is just going to be called an nth degree. Again, the names get really weird and confusing. Going to keep it a little simple. So if you see a polynomial with an exponent of 4, it's a 4th degree. Exponent of 6, it's a 6th degree. So something like y equals 3x to the 4th minus 17x squared plus 21x would be a great 4th degree polynomial. Even though it's got this x to the 2nd and this x to the 1st, we always judge off of the highest exponent there. This is how we can name stuff by both degrees and by the number of terms. Let's practice a little bit. So here I've got a couple of different polynomials for us here. We're going to talk about its degree, the name by its degree, the number of terms, and we're going to name it by the number of terms it's got. All right, so this first polynomial, we've got 3x minus 17. We're looking for that highest power for the degree. You're looking at those x terms. There is no number on that x. That does not mean it's 0. Remember, that's that invisible 1 hanging out there. So our degree here is 1. A first degree polynomial is a linear. Right? How many terms do we have here? We've got 1 minus sign, so you got your 3x, and you got your negative 17, so there's 2 terms. That makes it a binomial, naming by terms. Right? So this is a linear binomial polynomial. Right? Next one, x cubed. Well, there's not really any guessing here. The 3 is the only exponent we see, so the degree is 3. And we learned a new name for that today, cubic. This is a cubic polynomial. There are no pluses or minus signs hanging around, so there's only one term, which makes this a monomial. So this is a cubic monomial. Right, next term, or the next polynomial up here, we've got a power of a 4, a power of a 2, and technically a power of a 0. We got to pick one of those to be the degree. Remember, degree is always the highest power you see. So degree here is 4. Right, so this is going to be a 4th degree polynomial. You didn't have any special name for that. And it's got 1, 2, 3 terms separated by pluses and minus signs. So this is a trinomial. Fourth degree trinomial. All right, we've got 3 more here. Highest power is a 2, so that makes it a quadratic. And it's got 1, 2, 3 terms again, so it's another trinomial. Right, 2 more. I don't see any x's at all. That should give you a hint. Degree is going to be 0 here. No x's, degree is 0. That makes it a constant. Right, it doesn't change no matter what x is. It's just always -3. Right, constant, just one term, is a monomial. And technically, all constants are monomial, so if you say something is a constant, you don't have to call it a monomial also. That's just a given. And then finally, this last one, highest power I see is a 3, so that makes it a cubic again. And it's got 1, 2 terms separated by that minus sign, so this is a binomial. So we've got a cubic binomial. Right, so when you're classifying all of your polynomials, important things are highest power. That's going to tell you the degree of that polynomial. If it's got a 4, a 5, and a 6, that 6 is the biggest one, so it's a 6th degree. You can also classify by the number of terms. Just count them up in between those pluses and minus signs. All right, this time we're going to take a look at polynomials again, and we're going to get a feel for how we can combine them with some addition, some subtraction, and some multiplication. So remember when we were adding like linear functions together, we would just take the like terms and put them together? Same sort of deal here. And when we were multiplying like some quadratics or some linears, we would just FOIL, right? Same sort of idea is going to happen to them. So let's jump right in and try out some addition and some subtraction of these polynomials. So again, it's just combine some like terms. Now, not everything is going to have a match with the other polynomial, right? So this first one is a quadratic trinomial. The second one is a fourth degree trinomial. This one's highest power is a 2. That one's highest power is a 4. But that's okay. We can still add them together. It's just that this 4, the power of 4 is not going to have a term over here to match with. So let's find our like terms. We've got a squared term and a squared term. We'll add those together. We've got an x to the first power, and we don't have an x to the first power. That's okay. We've got a constant term, and we've got a constant term without x's. And then we've got that x to the fourth power that we talked about. So 0x to the fourths plus a negative 8x to the fourths is negative 8x to the fourth. Right, so we've taken care of that one. Next highest power is 2, so let's add those squareds together. 3x squared plus 2x squared, that's a positive 5x squared. We've used those ones now. Right, next x to the first power. So plus 8x, because there's no x to the first power in that other side. And then our constant's negative 7 plus a positive 3, that's a negative 4. So when we add these two polynomials together, we get negative 8x to the fourth plus 5x squared plus 8x minus 4. Now, normally you would list those terms in order from power highest to lowest. So we went 4, then 2, then 1, then 0. It's okay to leave them in other orders. It's just the standard format that you're going to see most of the time is just descending power order. Right? Let's try some subtraction. Now, if you don't like picking out the like terms this way, you could also stack them vertically like you first learned how to subtract like 2-digit numbers. So let's try it that way. So let's rewrite it so that we've got this guy minus that guy, and they're vertically stacked. So something like 15x cubed, that should be a cube. You're going to want to leave space for your missing terms. So this one doesn't have an x squared, so add a 0x squared in there, plus a 7x. And then you don't have a constant term, so add a 0 on there as well. Then we're going to subtract away this whole polynomial. So we've got a 3x cubed, a positive 5x squared, a negative 2x, and a positive 17. And then now we've got our terms just lined up. We'll just take our top things, our top terms that match, subtract the bottom terms that match. So we can take, starting at either end, doesn't really matter. We'll take our 15x cubed and subtract 3x cubes and get 12x cubes. Then we take a 0x squared minus a 5x squared and get a negative 5x squared. We'll take our 7x's minus a negative 2x's, so add that opposite, get positive 9x, and then you'll have 0 minus 17. So when we subtract these two polynomials, we get 12x cubed minus 5x squared plus 9x minus 17. So adding and subtracting, it's all about combining those like terms. Let's do some multiplication. Right? We have seen a binomial times a binomial before, but normally it was something like x plus 2 times x minus 3, right? We've got higher powers going on. The process isn't going to change. Our answer is just going to look a little bit different. So we get to FOIL these. So our first one, so we'll take 8x to the fourth times 2x cubed. 8 times 2 is 16. And then x to the fourth times x cubed, you're going to add those exponents together. You get x to the 7th. right? First outer is next. So 8x to the fourth times x. It's going to be 8x to the 4 plus 1 power is 5. First outer inner, so we get 7 times 2x cubed. That's a positive 14x to the third power. And then finally we have last. So 7 times x is 7x. Now once we've got those all multiplied together, you should check to see if you've got any like terms. Remember, those terms have to have the exact same variable part, meaning for us today that it's got to have the exact same power. But notice all those powers are different, right? 7, 5, 3, and 1. We cannot combine any like terms. There are no like terms. That's our answer. 16x to the 7th plus 8x to the 5th plus 14x cubed plus 7x. All right? So that one worked exactly like the binomials we've seen before. Let's extend this idea of FOIL to something that isn't a binomial times a binomial. How about a binomial times a trinomial? All right. So remember, everything from the first thing got multiplied to everything from the second polynomial. So this 8x got multiplied to both parts. This 7 got multiplied to both parts. I bet if we take this 3x and multiply it to all three parts, we should be good to go, as long as we also multiply this 1 to all three parts. Let's try it and see what happens. So 3x times 6x cubed, that's going to be 18x to the 1 plus 3 is 4 power, right? This 3x also gets multiplied to that 2x. So 3 times 2 is 6. X to the first times x to the first, 1 plus 1 is 2 for those powers. And then finally our 3x to the 5, that's 15x. All right, halfway done. We got to take this 1 and multiply it to everything. 1 times anything is just that anything, so the second half is going to be really easy. 6x cubed plus 1 times 2x is 2x, plus 1 times 5 is 5. Now we should have some like terms here. Again, they've got to have the exact same powers. All right, we've got a fourth power, that's the only fourth power. A second power, that's the only second power. A first power, okay. Those two are like terms, x to the first power. We get to add them up. That should be 17x, right? 15 is 2 is 17. Only cubed and only constant. So we're going to rewrite this and replace our 15x and our 2x with that 17x. So our final answer should be 18x to the fourth plus, I'm going to write this 6x cubed next, just going in descending order of exponents, plus your 17x, and then plus 5. All right, so there is our polynomial multiplied out together. Again, two polynomials multiplied together gives us another polynomial. That's an idea of closure. All right, one last set here to multiply. We've got a trinomial times another trinomial. So we're going to have 9 little multiplications here, and then we'll go back and combine those like terms. So 2x cubed times 4x squared, that's 8x to the 3 plus 2 is 5. 2x cubed times negative x, so that's negative 2x to the fourth. 2x cubed times negative 1, that's negative 2x cubed. All right, now we'll go to our middle term and multiply it to all 3 of the right polynomial. So x times 4x squared, that's 4x cubed. X times negative x, that's negative x squared. X times negative 1, that's negative x. And then one more, we'll take this negative 1 and multiply it around. So we get negative 4x squared, we get positive x, and positive 1. Fantastic. Like we said, 9 terms in this new polynomial, but anything that's a like term can get combined, right? This is the only x to the 5th, so I'm just going to write it down in our answer. We make that look a little nicer. All right, there's our x to the 5th. This is our only x to the 4th, minus 2x to the 4th. All right, looks like we've got a couple of x cubes here. Negative 2 plus positive 4, that's positive 2x cubes. Those are gone. We've got a pair of x squareds here. So we've got negative x squared minus 4 more x squared, so that's negative 5x squareds. We've got a pair of x terms. Negative x plus positive x is 0x, so we don't have to write it down. And then our constant of a 1. Right, so when you are combining like terms, either when you're adding or when you're getting to the end of your multiplication, don't forget like terms have to have the exact same variable part. If they don't have the same power, they aren't like terms.
Oh, yeah. Well, I mean, they haven't said anything. Hmm. I got chicken tacos. They were good. They always do, but yeah. Yeah, it was okay. Yeah. I just don't. Eh. Yeah. What the fuck?
Are you okay? That was a nasty hit. Turn the engine off and wait for the marshals.
Uh-huh.